So in this video we'll be parsing the headers in the PE file. So in order to load the PE file from memory, you need to have that in the byte array format, so we can load properly. So it's easy. So we can just download the file content using the web client.download string. So after downloading, you can we'll be parsing the file and loading into the memory and execute it. So first you need to do is you need to go to this p invoke and search for all of these headers, image DOS header, and you need to copy this structure, because we'll be parsing these many bytes, number of bytes into this structure to access these members easily, because every time we cannot remember the offsets of this particular PE file, and these offsets changes at this LFNU because of the DOS stub. So that's why we'll be parsing entire content and to get the easy access of values. If you it takes some time to copy all of this, you can just go to this my GitHub repository Win Security and go to this offensive C# and PE64 loader is working fine, and this 32 it's not working. I don't know, I should debug that and fix the problems. So this 64-bit is working fine. You can go to this program.cs and copy all of this starting up to main function. So copy all of these headers. You can see all of these structures, image file header, and if you expand this, we will have all of these the file header members. So we have already seen in the PE file format the same structures. So I have already copied this. Before that, we will be writing two functions to get the total image size. So how you gonna get total image size? Using this optional header, you will have size of image. So this content should be retrieved before loading, before we are doing anything. So let's do that. Public static int get image size of byte array. So we'll be passing the byte array. So how you gonna get the byte array is so for demonstration purposes we can just use file dot read all bytes. Let's say exe path is this one. So we have successfully read the content of this exe. Now we can go and parse this int size or image size is equals to 0, and this value will be returned. So first what we are going to do is we need to find this ELFA new value, because this points to straightly to the this PE header. So from the PE from the starting of the PE header, the offsets are always constant, only this junk differs. So this is the 64 bytes and this is 60, 61, 62, 63. So from starting so let's declare a byte array LFNU of size 4 to store these 4 bytes into this array. So for I is equal to 0, I less than 4, or we can say LFNU dot size dot length I++. So this is a good way of writing the code instead of using number 4. Of course both are same, but whenever you want to change the size, you can change here at one place instead of changing at both places. So we are going to read this offset of 60, because this is a 60, 61, 62, 63. So raw file of I is 0, so we need to add plus 60, and then in the next iteration it will be I is equals to 1. We will read the byte 61th byte. So we can assign LFA new of I is equals to raw file. Now what we need to do is, so there is this unsafe, so we can right click on properties, go to build and allow unsafe code. I have also imported these functions from previous files. These are simply the definition you can find in MSDN to save some time. So you can just directly copy from pinwork as well. There should be some changes to be made in the when you import from pinwork. So some parameters are treated as uint pointer instead of uint. So whenever you think that should be uint 32, so you need to change that to uint 32. So anyway, let's we have read the LFA new, so we can use bit converter dot to int 32 because of 4 bytes LFA new comma 0. So int offset we can go and print this ELFA new, and now what we can do is we can say int image size is equals to get image size of raw file. So let's just print this value, and the value is 200. So it's in decimal format, so you can go and say toString of capital X that represents hexadecimal, and we get the value C8. So we have this LFA new, and we need to now calculate the offset of size of image from the PE header. So the signature is 4 bytes, that is these 4 bytes, and the next 20 bytes are file header. So these 4 bytes and next 16 bytes. So this full this 24 bytes are the signature and the file header. So what we can do is we can say ELFA new is plus is equals to 24. So we have advanced to this starting of optional header. So from optional header we can check here the offset. You can see there are two versions, optional header 32 and 64. I'm using the optional header 64, and also right click on properties and change this to x64, and the offset for the image size of image is 056. I think it's 60 is the offset, I think. So let's go and try that. I think 56. So let's try 56 first. Press 56. Now we can go and say size of image is equals to new byte of 4, and the same way we are going to read this 4 bytes, because the it's 4 bytes. Size of image raw file of ELFA new plus I. Let's go and print this size of image so let's go and run this one, and we got the exact value 4190. And this should be assigned to image size, that is the returning variable. Is equals to, now the image size will be here. Now we can go and print this image size 16784, and the value is 4190, so the same value. Now we are good to go. We got the image size. The next thing we want to get is size of headers. You can see the offset is almost same, only the difference is 8C, so 4 bytes. So what we can do is we can copy entire code and change the function name to get headers size, and you need to add press 4 to this. So very simple. So you can change the variable names, but it does not matter, those are local variables. Now we can say int headers size is equals to get header size of raw file. Now if we go and print the header size dot toString, and we get the value 248, and it's 248. So we got the header size and the image size. So I think we are good to go. Now what we are going to do is we can directly parse our raw file, that is raw data raw file. But what we're going to do is we are going to allocate some this much amount of memory into the own process, so that we can marshal easily. So don't worry. So let's just do virtual alloc. Virtual alloc int. First one is we can pass null, so the operating system will decide. Allocation type. So the size, what we are going to do is first we are going to allocate the size of headers, because first we want to parse the header size, and the next one is allocation type, that is mem commit, and the protection type is read write execute. So what we can do is we can say read write, and then we can change that to read only by virtual protect, later on when you are writing the headers, or you can later at the end of before executing the code, you can change that to sections to the executable and then can execute. But just for the tutorial purpose, I'm going to use read write execute for the entire memory. This gives us the starting address where the block has been allocated. Let's call this as base address. So we have allocated some memory and we need to free this memory. So we need to use virtual free. So virtual free, I already imported virtual free. The first is the base address and how much size you want to free and the free type. So what we're going to do is if we give the memory release, the entire whole block will be released. So the base address, and if you give the memory release, this size parameter should be 0. So 0 and memory release, the value is this one. So let's go and put a breakpoint at this. So at this virtual free, and let's go and start debugging. And here we can see the application has been froze. Now let's go and open a memory window. Okay, we don't know the base address because we're not printing. So let's go and print this. Memory allocated at base address dot toString. Okay, now we know the base address. Let's go and run this. Now copy this address and paste here. Put 0x, and here we can see the zeros of our block. Now if I go and step into this, we can see virtual free has executed and we have this data has been freed. So let's go and continue this. Now what we're going to do is we are going to copy the contents from the raw file. So we can do that using marshall.copy source. So the byte array source, that is raw file, and the starting index is 0 and the destination is where you want to write, that is at my base address, and how much the length you want to write. So here I am specifying header size because in this video we are parsing only header size. Okay, we have successfully copied. Now let's go and put a breakpoint at this marshall.copy, and now copy this address. So you can see we have all zeros before this marshall.copy instruction. So let's go and execute step into this, and here we can see 4D5A, the exact so the red color data is the modified bytes. You can see the exact data has been successfully stored in this memory. So you can compare here the exact data. So now let's continue this, and the data will be freed. Okay, since we are putting breakpoints, let me comment out this console.read key. Now we have successfully copied the file into the memory. Now we can marshal this structure easily. Otherwise you wanna find every offset like we have done here, so it's gonna take so much time. So we can say marshal dot pointer to structure. So the pointer is base address, and I want to marshal the type as DOS header. So the type is image DOS header. Now the first 64 bytes have been marshaled into the structure image DOS header. So that means the first it will be read the size constant 2. So the first bytes will be read and will be stored into the structure members. Now what we can do is we can simply print the DOS header dot magic dot to string. So you don't need to copy. You don't need to use for loop to copy first 64 bytes and then parsing then each and every member. So you can just directly marshal this one. So I can just run this and we can see output mg. So you can see mz means the magic bytes of PE file. You can also print out DOS header dot elfa new dot to string. Okay, so I did not put breakpoint. Now we can see the C8 value. So it's very lot easy. Now we need to parse the next header, that is nt header. So we can say nt header 64, nt header is equals to new nt header. We can just first we need to marshal from this point onwards up to this section headers. This is the nt header. So nt header contains 3 members, that is signature, file header and optional header. So we are marshalling or parsing 3 headers at the same time in a single shot. So marshal dot pointer to structure, and the base address is base address plus how much you want to add to this to get to this nt header. That means this LFA new. If you add the base address to this value, you will get to this starting of nt header. So we have already parsed this DOS header into this structure. So I can just say DOS header dot elfa new. So it's very simple. You don't need to again store it in any other variable. We are directly storing it in structure itself. And the type of, so into which structure you want to marshal I want to marshal as optional image nt header 64. And we can say nt header, and the type should be cached into this nt headers. Now it's very easy. We can just go ahead and print whatever we want. Nt header dot file header, optional header, signature. So we can print the signature dot to string. So what is the signature? Of course this is the PE. So we got 4550. So you can convert this into normal string as well. So you can just go ahead and print everything, so whatever we are interested in. So you can basically write a parser as well. So let's go on print nt header dot file header dot number of sections. So this number of sections will be needed later to map the sections, but you don't need to store it in any other variable because we are already having this structure. So you can go ahead and now print whatever you can. Now we need to parse the section headers, right? So for that, what we need to do is we need to create an array of section headers, because there may be more than one sections. I can say sh is equals to new image section header of. So how many of these arrays are there that are defined by nt header dot of file header dot number of sections. So if you go to this file header, we will have number of sections, that is 3. So those many amount of number of sections we have. So we can say nt header dot file header dot number of sections. So we have an array of section headers waiting to be filled. Okay, now what we're going to do is for int I is equals to 0. So how many times we want to parse the next upcoming section headers? You can see here dot text, so r dot r data and dot fyff. So there are 3 sections, so we're going to loop 3. So these value points to 3. So we can use this one, nt header dot file header dot number of sections I plus plus, and we want to marshal the size of the section header. So obviously we can just use sh of I is equals to marshal dot pointer to structure. So how to get the pointer is so we have base address plus elfnu plus elfnu gives to this one, and then what we can do is we can add the sizes of this nt header dot file header plus option header. So that should give you the offset to this dot text. So let's go and try that. Base address plus DOS header dot elfnu plus marshal dot size of nt header dot file header plus marshal dot size of nt header dot signature. We all know it's 24 bytes, right? So we can just delete all this. So the file header and the signature are 24 bytes. And the next one is size of option header. So how you define the size of option header is nt header dot file header dot size of option header. So this should give you the offset to this first section. And if you want to get the offset to the next section, you need to multiply, you need to add the section header structure. So what we can do is we can say marshal dot size of type of section header, and we need to multiply with I. So for the first iteration we are multiplying with 0, so this gives 0, and this one is the starting offset of this first section. In the second iteration I value takes 1 and 1 into size of section header. So size of section header is 40 bytes, I think. So 1 into 40 gives 40. So from this point onwards we are moving 40, and after that I value takes 2 into 40 80. This is already the base, that is this one, base of the first section, and plus 80 gives the third section. So I hope this is clear. Now I have to worry about these brackets. Type of section header. So okay, this is looking uglier. So let's convert this into 2 in 64. Okay, so that bracket is missing, so I think we are good to go. So we up to this point, all the sections should be marshaled to this one section here. Now I can verify this sh of I dot name. So this should give the name of all the sections. So let's put the breakpoint and run this, and we can see the sections, all of the 3 sections has been successfully marshaled. We can also print those sections. Members, so and you can see 400 1600 1800. So we have successfully parsed the PE headers.